Out there in the wilderness, when a mountain man's rifle failed, he had one choice: build a bow or starve. A broken firing pin, wet powder, or lost ammunition could turn a deadly marksman into helpless prey in minutes. They needed weapons they could craft from nothing but trees and sinew. They needed bows that could kill game at 50 yards with primitive arrows. They needed skills that could transform a piece of wood into a precision hunting instrument using only hand tools. The men who lasted decades in the wilderness had mastered bow-making techniques that were more sophisticated than most modern archery equipment. Skills that could create deadly accurate weapons using only what the forest provided. But how did mountain men select the perfect wood for survival bows that could last for years? Which shaping techniques and tillering methods ensured maximum power and accuracy? And what secrets did they use to create bowstrings and arrows that were as effective as modern equipment? Today, we're exploring the ancient art of survival bowmaking, techniques that kept mountain men armed and dangerous when everything else failed. My name is Sam, and this is Wild America. The wood selection, finding the perfect stave in the wild. The morning frost clings to the bark as mountain man Samuel Bridger runs his weathered hands along the trunk of a young yew tree, feeling for the grain patterns that will determine whether this wood can become a weapon that saves his life. His rifle took a tumble down a rocky slope yesterday, and now his survival depends on his ability to craft a bow from whatever the mountain forest provides. The wood selection process was the foundation of every successful survival bow, and mountain men understood that not all trees were created equal. The ideal bow wood had to possess a unique combination of characteristics: flexibility to bend without breaking, strength to store and release energy efficiently, and grain structure that would remain stable under the extreme stress of repeated drawing and shooting. The species identification required intimate knowledge of forest ecology that took years to develop. Yew was the gold standard. Its combination of elastic sapwood and compression-resistant heartwood created bows that could match the power of much larger weapons. Osage orange provided incredible durability and cast. Hickory offered reliability and forgiveness for less experienced bow makers. Each species had unique properties that affected the final weapon's performance. The tree assessment went far beyond simple species identification. Mountain men learned to read the subtle signs that indicated wood quality: the straightness of grain, the absence of knots and defects, the proper moisture content, and the age of the tree. They could determine by touch and visual inspection whether a piece of wood would make a reliable bow or fail catastrophically when put under stress. The harvesting timing was critical for creating bows that would last for years of hard use. Wood cut during the dormant season had lower moisture content and more stable grain structure. Trees stressed by drought or disease produced wood with unpredictable characteristics. Mountain men learned to time their wood harvesting to coincide with optimal conditions for bow making. The stave selection process required understanding how different parts of the tree would perform as bow limbs. The best staves came from the outer portions of the trunk where the wood was under natural tension. Branches and inner wood lacked the proper grain orientation for reliable bow performance. Mountain men could identify the perfect stave location by reading the tree's growth patterns. The initial processing had to preserve the wood's natural characteristics while removing excess material. Mountain men used axes and knives to split staves along the natural grain lines, understanding that cutting across the grain would create weak points that could cause catastrophic failure. They learned to follow the wood's natural structure rather than imposing artificial shapes. The seasoning process prepared the wood for the intensive shaping that would follow. Green wood was too unstable for immediate use, while over-dried wood became brittle and prone to breaking. Mountain men developed techniques for accelerating the seasoning process when time was critical, using controlled heat and airflow to achieve optimal moisture content quickly. The quality assessment determined whether a stave was worth the time and effort required to complete a bow. Mountain men learned to identify fatal flaws early in the process, saving precious time and energy for staves that had the potential to become reliable weapons. This assessment required understanding wood mechanics that was gained through years of trial and error. This wood selection and preparation process was where mountain men's expertise truly showed. The ability to identify and process perfect bow wood under survival conditions was a skill that separated successful wilderness survivors from those who starved despite being surrounded by potential bow materials. The knowledge required understanding botany, physics, and material science that was passed down through generations of wilderness experience. The shaping process, from rough stave to precision weapon. The afternoon sun filters through the pine canopy as Bridger carefully removes another thin shaving from his bow stave, each cut bringing the weapon closer to the precise dimensions that will determine its power, accuracy, and reliability. 3 days into the shaping process, and the rough piece of yew is beginning to reveal the deadly weapon hidden within its grain. The layout process established the bow's basic geometry and determined its final performance characteristics. Mountain men learned to read the natural characteristics of each stave and design the bow to work with the wood's strengths while minimizing its weaknesses. They marked the handle location, limb tapers, and nock positions with precision that would determine the weapon's balance and shooting characteristics. The roughing out phase removed excess material while preserving the wood's structural integrity. Mountain men used axes, knives, and improvised tools to shape the stave into the basic bow profile. This process required understanding how much material could be removed safely without weakening the bow, and how to maintain symmetry that was essential for accurate shooting. The tillering process was the most critical and skill-intensive phase of bow making. This involved gradually removing material from specific areas of the limbs to achieve even bending throughout the bow's length. Mountain men developed techniques for testing the bow's bend pattern and identifying areas that needed adjustment. Poor tillering could create weak spots that would cause catastrophic failure. The tool improvisation required creating precision cutting implements from available materials. Mountain men learned to make scrapers from broken glass, sharp stones, and metal fragments. They created measuring devices from string and sticks. They developed sharpening techniques that could maintain tool edges using only natural abrasives found in the wilderness. The thickness tapering created the precise cross-sectional changes that determined the bow's power and shooting characteristics. The limbs had to taper from thick at the handle to thin at the tips, with smooth transitions that distributed stress evenly. Mountain men learned to achieve these precise tapers using only hand tools and visual assessment. The width profiling shaped the bow's side-to-side dimensions to optimize performance while maintaining structural integrity. The handle area needed to be wide enough for a secure grip, while the limb tips had to be narrow enough to minimize mass and increase arrow speed. This profiling required understanding the relationship between bow geometry and performance. The string groove cutting created the nocks that would hold the bowstring securely while allowing smooth string release. These grooves had to be precisely positioned and shaped to prevent string slippage while avoiding stress concentrations that could cause tip failure. Mountain men developed techniques for cutting perfect nocks using only knives and improvised tools. The final shaping involved countless small adjustments that refined the bow's performance and shooting characteristics. Mountain men learned to identify and correct minor imperfections that could affect accuracy or reliability. This final phase required the patience and skill that came from years of experience with bow making and shooting. The testing process verified that the bow could handle the stresses of repeated shooting without failure. Mountain men developed methods for gradually increasing the draw weight and testing the bow's limits safely. They learned to recognize the signs of impending failure and how to make corrections before catastrophic breakage occurred. This shaping process transformed a rough piece of wood into a precision weapon that could reliably kill game at hunting distances. Mountain men who mastered these techniques could create bows that were as effective as modern equipment while using only primitive tools and natural materials. The skills required understanding physics, engineering, and material science that was gained through practical experience and life-or-death necessity. The string and arrow system, completing the weapon. The evening campfire casts dancing shadows as Bridger carefully twists sinew fibers into the bowstring that will complete his survival weapon. The bow is perfectly tillered and ready for testing, but without a reliable string and arrows, it's nothing more than an elaborate piece of carved wood. The string material selection was critical for creating a bowstring that could withstand the enormous forces generated by a hunting bow. Mountain men learned to identify and process materials that had the strength, elasticity, and durability needed for reliable bowstrings. Sinew from large game animals provided the ideal combination of characteristics, while plant fibers offered alternatives when animal materials weren't available. The sinew preparation process required understanding anatomy and fiber processing techniques that maximized string strength and durability. Mountain men learned which tendons provided the best string material, how to extract and clean the fibers, and how to prepare them for twisting into strong, flexible strings. This process required patience and skill that took years to master. The string construction techniques created bowstrings that were stronger and more reliable than many modern alternatives. Mountain men learned to twist fibers with the proper tension and direction to create strings that would stretch minimally and resist breaking under stress. They developed methods for splicing and reinforcing strings that could last for thousands of shots. The string length calculation ensured proper bow performance and shooting characteristics. The string had to be exactly the right length to create the proper brace height, the distance between the string and the bow handle when strung. Incorrect string length could dramatically affect the bow's power, accuracy, and reliability. The arrow shaft selection required finding straight, strong wood that could be shaped into projectiles capable of penetrating game animals. Mountain men learned to identify trees and shrubs that produced arrow-quality wood, understanding the characteristics that made some wood superior for arrow making. They developed techniques for straightening naturally curved shafts using heat and pressure. The arrow point creation involved crafting deadly broadheads from available materials. Mountain men learned to knap stone points that were razor-sharp and aerodynamically efficient. They developed techniques for working metal when available, creating points that could penetrate the toughest hide and bone. The point attachment methods ensured that arrows would remain intact during impact. The fletching process added feathers or other materials that stabilized the arrow in flight and ensured accurate shooting. Mountain men learned which feathers provided the best flight characteristics, how to attach them securely, and how to trim them for optimal performance. Poor fletching could make even a perfectly made bow inaccurate and unreliable. The nocking system created the interface between arrow and bowstring that allowed consistent, accurate shooting. Mountain men learned to cut precise nocks in arrow shafts that would grip the string securely while releasing cleanly. The nock size and shape had to match the string diameter and shooting style for optimal performance. The testing and tuning process ensured that the complete bow and arrow system worked together for maximum effectiveness. Mountain men developed methods for testing arrow flight, adjusting bow performance, and fine-tuning the entire system for hunting accuracy. This process required understanding ballistics and shooting mechanics that was gained through extensive practice. The maintenance protocols kept the bow and arrow system functional through extended wilderness use. Mountain men learned to protect strings from moisture, repair damaged arrows, and maintain bow performance in challenging conditions. They developed techniques for field repairs that could restore a damaged weapon to full functionality using only available materials. A bow without arrows is just a stick, and arrows without a bow are just sticks, explained mountain man Jim Bridger in 1835. But put them together right, and you've got a weapon that can keep a man alive when everything else fails. This string and arrow system completed the transformation from raw materials to functional hunting weapon. Mountain men who mastered these techniques could create complete archery systems that were as effective as modern equipment while using only materials found in the wilderness. The knowledge required understanding physics, engineering, and craftsmanship that was essential for wilderness survival. The hunting application, putting the bow to deadly use. The pre-dawn darkness is broken only by starlight as Bridger moves silently through the forest, his handmade bow strung and ready, an arrow nocked and waiting. After a week of intensive work, his survival weapon is about to face its ultimate test, putting meat on the table when failure means starvation in the unforgiving wilderness. The shooting technique required for hunting with primitive bows was far more demanding than modern archery. Mountain men had to compensate for the limitations of their handmade equipment through superior shooting skills and intimate knowledge of their weapons. They learned to shoot instinctively, without sights or mechanical aids, relying on muscle memory and thousands of hours of practice. The range limitations of survival bows required hunting strategies that brought mountain men within close range of dangerous game animals. Unlike modern compound bows that could kill effectively at 60 yards or more, primitive bows were most effective at ranges under 30 yards. This meant mountain men had to become expert stalkers who could approach game undetected. The shot placement knowledge was critical for making clean, ethical kills with relatively low-powered weapons. Mountain men learned the anatomy of every game animal they hunted, understanding exactly where to place arrows for quick, humane kills. Poor shot placement could result in wounded animals that escaped, taking precious arrows and leaving the hunter without food. The arrow recovery system ensured that valuable projectiles could be retrieved and reused. Arrows represented hours of work and precious materials that couldn't be wasted. Mountain men developed techniques for tracking wounded game and recovering arrows from successful kills. They learned to make arrows that would penetrate completely for easier recovery. The hunting strategy adaptation took advantage of the bow's unique characteristics while compensating for its limitations. Bows were silent, allowing mountain men to take multiple shots without alerting other game. They could be used in weather conditions that made firearms unreliable. But they required different hunting approaches that maximized their effectiveness. The game processing techniques ensured that successful hunts provided maximum nutrition and materials for survival. Mountain men learned to field dress game efficiently, preserving meat for jerky making and utilizing every part of the animal for tools, clothing, and other necessities. Nothing was wasted when survival depended on making the most of every resource. The arrow maintenance protocols kept projectiles functional through extended hunting expeditions. Mountain men learned to sharpen points, repair fletching, and replace damaged components in the field. They developed techniques for creating new arrows from available materials when original supplies were exhausted. The backup planning ensured that bow failure wouldn't result in starvation. Mountain men always carried materials and tools for emergency bow repairs or replacement. They learned to identify potential bow wood during their travels and could create emergency weapons quickly when necessary. The seasonal adaptation techniques adjusted hunting strategies to match changing conditions and game behavior. Mountain men understood how weather, food availability, and breeding cycles affected game movement and behavior.